Hey class, Mr. Moyden here with a calculus video regarding simplifying a definite integral or evaluating a definite integral. So we're given this problem here, the definite integral, the summation from -4 to 2 of this rational function, 6x minus 42 over x squared minus 49 with respect to x. So at first it looks a little intimidating. You probably can realize that this integrand can be simplified significantly. So we'll actually start off by doing that. Maybe that'll make our integration a bit easier. So from -4 to 2, we have, well, the numerator seems to be 6 times the quantity x minus 7 if I factor a 6 out. And likewise, the denominator appears to be x minus 7 times x plus 7. This gives me the following cancellation. So I can rewrite this problem as the integral, the summation from -4 to 2 of 6 over x plus 7. So that looks a little bit better. I can furthermore write this as -4 to 2. I can quote-unquote factor out this 6 from my integral because it's a constant multiple. We'll talk a bit more about properties of definite integrals later this week, but that's a pretty straightforward one. And now my problem starts to come into focus, which is to say I have an integral of 1 over some math, and that math's derivative is just 1 here, right? So just 1x, so I don't really have to worry about the reverse chain rule, which is to say, using the fact that the integral of 1 over x dx is ln of the absolute value of x, I can therefore say that by the fundamental theorem of calculus, I can use the antiderivative to calculate the area under the curve, or the summation. So my argument here is x plus 7, so ln of the absolute value of x plus 7, and I'm going to evaluate that from -4 to 2. So this is just a mathematical convention that we use in the field regarding notation. The fundamental theorem of calculus is I evaluate at the upper bound, I evaluate at the lower bound, and I subtract those two evaluations. So evaluating there by the fundamental theorem of calculus, that would give me ln of b, f of b, which would be 2 plus 7 absolute value, minus, that comes from the fundamental theorem of calculus, ln of -4 plus 7. So you can see what the absolute value bars would be useful here, perhaps. 6 times, let's see, ln of 2 plus 7 would be 9, absolute value of 9 is still 9, so ln of 9, minus ln of, see, -4 plus 7 is 3, absolute value of 3 is still 3. Okay? Well, by the properties of logarithms, you should know that this can be written as the ln of 9 over 3, which of course is just 3. So the problem furthermore becomes 6 times the ln of 3. And also by properties of logarithms, you know that this can be written as ln of 3 to the 6th power, which I believe is ln of 729. So it appears that's our answer. It's a little bit of a funky answer, a weird one, so let me just make sure here. I'm going to go to my calculator, and I'm going to take the definite integral from of numerator 6x minus 42 over x squared minus 49 with respect to x, from -4 up to 2. Give it a moment to think, and I get that unusual number. Well, I posit that ln of 27 is that number. Well, let's find out. What is ln of 729? Is it 27, 729? Well, hey, it's the same number. Hope this helps.